Hey, hello, hi, welcome to a laser cutting tutorial, and actually not even laser cutting, but rather preparing your files to be cut by a laser type of tutorial. In this video I'll show you my process and how I tackle this problem, and it might not be the most optimal way of how to do it, but hey, that's the one that works for me every damn time, so I'm sticking with it and I'm making a tutorial about it. So hopefully it's gonna help you out as well. Okay, so I guess without any further blah blah blah, let's just jump right into it. First step. The first step is always building a 3D model of the physical model that you're going to be making. And you do this because during the construction of it, you first choose what kind of material you will use, as well as you plan ahead. You plan for how you're going to be constructing it. The time that you sink making this kind of comes back when you don't need to kind of scratch your head and figure out connections later down the line as you're building it in the real world. In my case, I chose to use 1mm balsa wood for the exterior, for the cladding and whatnot, as well as the terrace. 2.4mm balsa wood for the inner structure, inner shell, so thick boys. 3x3mm pine wood long boys for the construction or for the poles, and 2mm cardboard because I will need a lot of it, so I chose a cheap material. The reason why we kind of make this is because, for instance, here I have my poles already modeled out into the landscape, right? So they penetrate the landscape, meaning that once I have the 3D model of just the landscape, it already has holes for the poles. And once I add the poles here, I will have a really good understanding of how everything needs to fit together, right? So the tolerance of the building itself, of the building model itself, will be pretty low, right? So that's one of the benefits. Anyway, I'll show you a quick little clip, like a supercut, if you will, of me making this 3D model. Perhaps you're gonna learn something from that. It's just for fun, isn't it? Okay, let's watch it. Welcome back. So once the model is done, it's time to move on to actually creating 2D layouts of things that are going to be laser cut. And for that, we make measurements, we draw according to the measurements, we lay out every bit and piece flat on the ground, and then we kind of export it into our laser cutter. That's the short version of it, right? For this, I don't use Rhino. I use a different kind of software that is called ZWCAD, which is, by the way, also the sponsor of this video. But not to say that I only show it to you because they sponsored this video. This is actually a tool that I do use, right? It's a AutoCAD replacement that is cheaper and faster. So it's quite a no-brainer for me to use it. So I got really excited once they actually reached out to sponsor. Yeah, win-win. In terms of the workflow, the first step thing that I do is I get the 3D model in here just to be able to check if something is wrong. I tend to go back and forth between Rhino and ZWCAD in this kind of a workflow, but just having a 3D model here on the screen is also quite nice. So here in the command line, I'll just type in import. And from my desktop, I already have a SAT file exported from Rhino. So I just select it here in Rhino. You just select everything, you type in export, and you just choose acis.sat, and you just name it. I already have it, so I won't be doing that. So we select it, we hit open, and it's gonna import it. And it does not look great because we're watching it, you know, in a wireframe view straight from the top. So for that, we kind of need two viewports. We need the left one for the 3D and the right one for the 2D. And to get the two viewports, you click on this little minus sign right here, right next to top, the minus sign, and you choose viewport configuration list and choose 2 vertical, I believe. Yep, 2 vertical. So this one is gonna be of our 3D model, and this one, oops, this one is going to be of our CAD or 2D drawing, right? Or drawings. So for the 3D model, let's just switch from top view to perspective, like that. And then from 3D wireframe, let's switch to flat. There we go. That's all you need to do. So now to rotate, you press and hold Shift, and you hold the, or do you need to hold Shift? Yes. You hold Shift and you hold the scroll wheel and drag, and thus you rotate. If you want to pan, you just hold the scroll wheel without the Shift, right? You pan, and scrolling is zooming. That's the basic navigation. Okay, so just having it somewhere here, that's always nice for me, right? Just being able to zoom in and check without needing to tab out into Rhino. Okay, so the first step is actually to well, the first step is actually to get the nasty bits in, right? The nasty drawings in. And the nasty drawings are of these parametric bench, right? So this parametric bench is a little bit niche, and it's going to be a little bit weird, but since it's made with parametric software, I do need to use the parametric software to get the drawings out of it. But that is going to be a pretty good opportunity of me showing you how cleanly the CAD drawings from Rhino import into ZWCAD. Let me actually play you a quick little clip of me creating the parametric drawings from this particular portion. You can see the portion in dark green. I'll just play the clip so that you can understand what's going on, and then we're going to import the drawing, right? So clip time. Okay, so hopefully that was, well, some of you caught what was happening. It was basically just me laying out every single piece here flat on the ground and extracting the drawings from it, and then numbering, very important, numbering every piece and nesting it onto these rectangles. And I'll talk about that in just a second. So to import your exported DWG file, all you need to do is just go to where you have exported it. And by the way, you export the DWG exactly the same way as how you export the SAT. You select the drawing and you type in export. I have this parametric out.dwg. We just drag and drop it in, and there it is. We click and hit enter once, twice, 3 times. Right? So the first time that we click it, I believe is the scale in X direction, how big it is in the X direction. The second time we click it, we hit enter, it's the scale in Y direction. Third time we hit it, it's rotate 0. Basically, we were saying that it should not rotate. That's all it is, right? So this, all of these kind of more complex elements have imported here, and you can see that they import as a block, right? So if I select this, you can see on the right hand side here it says block reference, and that's typically how DWG files import into ZWCAD, which is absolutely fine. To get rid of the block, we can just explode it if you want to. We explode it, and now we have ourselves separate lines, right? And this is where I will need to just select these numbers and actually move them, enter, move them into the elements, because that was not done in the parametric software, right? So I'll spend some time doing that, and actually I'll do that off recording, so I will not record myself just moving every single element here, but this should be like a few minute workout section with me and my mouse. But that's not going to be recorded. What's going to be recorded though is, or some of it is going to be the measuring of these elements that we have here. For instance, the roof and so on, all of these segments, making measurements of those and actually drawing them here in the 2D view, getting ready to be laser cut. To actually measure them, I can type in distance, dist, and from this point, there we go, from this point until, there it is, I have 170 mil. And then if I repeat the command from this point on here to here, I have 81.3 millimeters. So 170.88 and 81.3. Now to actually draw out this piece, all I need to do is just, where is it? Just make a rectangle, right? So I'll just type in rectangle. Start from anywhere actually in the screen, but I will choose dimensions rather than specifying a coordinates. I will write dimensions, right? So I'll type in D, enter for dimensions, and now it's asking me to give it length of the rectangle, 170.88, enter, and the height 81.3. Come on, there we go. So that's, and also the orientation, you just click once. So that's my rectangle from here translated to here, right? So I will spend a little bit of time just going through all of these bits here, just making sure that I have drawn out every single one of them. And a trick is to actually, you can also do the same thing in Rhino in terms of the measurements, right? So you just go in here and you measure from this point to this point and you get the same 170.88 millimeters, right? But the trick in both softwares, no matter where you measure it, is to delete. So you select and you delete the elements after you have made the measurements, right? And after you have drawn them out. So you don't laser cut twice by accident some element, right? So that's the trick. Okay, let me go through this really quickly, or not quickly, but let me go through this off camera and just draw out every single piece that I have here. There we go, there it is. Okay, so as you can see, the 3D model is not exist. Oops. The 3D model does not exist anymore, meaning that all of the bits and pieces have been actually drawn out. Yay! Yay. Okay, so now we don't need the two viewports anymore, so we can actually click on this little plus sign and we can choose single viewport mode. So from now on, we're just in 2D. Now on to the next step, which is the landscape. And unfortunately, like for the landscape, you could get it through ZWCAD and you could kind of outline and draw out the outlines in ZWCAD. But the trick is to be as fast as possible, or not the trick, but the aim is to be as fast as possible. So instead, we just simply use Rhino to generate the drawings for each landscape piece, as well as numbering in a similar way of how we did the bench. And if you're curious to know more about this kind of parametric design, then I suggest that you watch my earlier videos about just about that, right? Because it's a huge topic and it's pretty hard to get into, and here I'm just showing you the basics, right? So with this, in terms of the landscape, let's just give me a second and I'll import it into my file. Yep, there it is. There it is. It's a long boy. It's for sure a long boy, right? We have plenty of these slices, which we'll need to pack as well as possible. And by the way, speaking of these slices and parts and packing, I forgot to mention that you always need to have this kind of a outer rectangle that is the size of the material, the sheets of material that you have. In my case, I have 10 by 50 centimeter sheets that I will be using, meaning that everything that I do needs to be packed into those sheets, right? Hopefully that makes sense. It should, right? So in terms of the landscape, my sheets are going to be 400 by 400 millimeters, right? So this one completely fills it up, while these ones might stack a little bit nicer. But basically, it's all trying to push things as neatly as possible. Okay, enough about that. Now on to actually preparing for laser cutting, right? Because now we have all of the material that we need. We have our bench, we have our the building parts, and we have our landscape parts. So now it's time to actually get going. Step one is to create two layers. Under layer properties, well, I imported a bunch, so there's a bunch here, but we click on layer properties, and here we just simply create new layer, and we will call this one cut. That's going to be our cut layer, and the cut layer is set to white. And then we will have another layer, new layer, and we'll call it engrave. Actually, let's make 3 layers. Sorry. Let's make 3 layers. Second one is called engrave, and that one is going to be full red. So you choose red color from here. Okay, white, red. And the third one, we call it sheets. And that can be green. There we go. Cut, engrave, and sheets, right? So basically, a laser can do low power engraving, high power cutting, or it can just ignore lines if they are in a specific layer, such as sheets. The sheets are only used for placement of the parts, not for cutting. So what I can do is now I can select these elements here, and I can just move them to my sheets layer, and you move them here by opening it up and choosing sheets. Bam. Easy. Now they're in the sheets layer, and I can actually hide it so that it's not getting in the way. Now let's deal with the curves here, right? Those need to be cut, right? So those will go into the cut layer. Let's first select this bad boy here, and just hide it. And once I have hidden it, there's one more, this one. Once I've hidden these 2 layers, I can just select all of the curves here, and I can just move them into my cut layer. Cut. Just like that. Perfect. And now I can temporarily hide my cut layer, enable my 2 of the imported engrave layers, enable them, select everything here, and just move that to the newly created engrave layer, like so. That's that. Now with all of this done, you can see we have our sheets, we have our cut lines, we have our engrave lines, and that's all there is to it, right? I will do the same thing. Well, this one is going to be easy, right? We just select all of it and we just changed it to cut. And this is going to be important. We select this, we change this to cut, and you can see they're still black. Why are they black? Well, that's because we changed the block to be in the cut layer, not the lines inside of the block. So the lines inside of the block are still in their whatever landscape layer they're in, right? So only the block is inside of the cut layer. That's a little bit annoying. So what we're gonna do is we're gonna select this, type in explode so that it's not a block anymore. Select all of them. Gets a little bit annoying with the selection, but it's fine. And just place it into the cut layer properly. Okay, so you can see at this point from the way I work with the software, it's basically very similar to AutoCAD, except that it also has a few kind of nice things about it. And I'll make a pause here to just kind of show you those things because I feel like that's interesting and important to talk about. So one little thing is the gestures, the mouse gestures. So if I press and hold my right mouse button, I can not type in, but I can make this kind of a L gesture, and it starts a command called line, right? So I can just draw a line. I can make a C gesture, and it draws a circle, right? I can make I can make a gesture from bottom up and it starts a new file. If I make a gesture from bottom down, it closes the file, which is a little bit dangerous. So don't do that, right? So to access all of these gestures, you can type in mouse. I'm trying to remember gesture, mouse, smart mouse config. Yes, smart mouse config, right? You enter it, and here you can see every single gesture that there is, right? So there's zoom, there's regeneration of the viewport, and so on. We'll talk about regen in just a second. Then there's the erase, right? So you can tailor your ZWCAD to fit with your workflow as much as you want. My suggestion would be to go in here and then immediately untick the close, the close gesture, because that might really mess things up for you real quickly if you're trying to go fast, right? But yeah, here you can just choose whatever gesture you want. You can type in the command and it's gonna simply work. Okay, save, we're done. So give me a second, I will clean this up, and as I'm cleaning it up, I'll figure out a way of how I can show you the speed of ZWCAD. Actually, before we start cleaning, sorry, I changed my mind. Before we start cleaning it up, I want to create hatches for the planks. So I think this building would look nice if it had planks. So what I want to do is I want to engrave the planks on top of the facade of this building, right? So everywhere here. And the way I laid it out here, it's kind of unfolded, right? So the hatch should fit quite well. So let's just make one, right? So I'm gonna engrave my active layer. That's because the hatch should be engraved. And I'll just type in H, enter, hatch, enter. Pick internal point, sure, that's my internal point, right? Doesn't look great, so let's start changing things around. ANSI31, the typical hatch that you all love, right? We choose that. And for the angle, I want it vertical, so we're gonna change it to 45 degrees. Something like that. Oh, at this point we can talk about regen. That's gonna be nice. Then in terms of where it should be anchored, I will just pick points and I'll click on Oh, my bad. That's picking internal point. Ugh, I'm being stupid. I'm sorry. Okay, so we select the hatch and we find, yeah, there we go. Set origin. That's the one where we can set up where it starts. So set origin. I click on the top of the roof. Store as default origin. Yes, and now this is going to be the new origin for every new hash that's going to be created, which in this case maybe was a bad idea, but doesn't matter. We'll adjust them. So all of these lines will be engraved, right? The problem is that most of the laser cutting software does not understand hatches, right? So what you need to do is you need to explode the hatch into separate lines, right? So make sure that you do that. All right, so I'll just go through all of this and I will add the hatch in to all of these bits and pieces. Let me just do a few more so that you understand what I mean. Something like that. Looks good. Something like that. That's off center, so I will fix that up by set origin like that. And I'll just go through the remaining ones, and now it's time to actually clean things up. Be right back. While other Gediminas is cleaning, let me show you a cool little thing about ZWCAD, which is actually the speed of it. I have this poster right here of our beloved CRT character that I've made in Rhino as well as ZWCAD. Actually a pretty similar workflow as what I have shown you today in this tutorial, right? So here we have a lot of lines and a lot of control points, right? It's a pretty heavy drawing, right? With a bunch of curves and then whatnot. And let's just simply import it and see if ZWCAD will handle it. Of course it will. I know already that it will. It's not even a question. Okay, so I'll just select the file, drag and drop it in. Like that, as per usual, scale factors, enter, 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 zoom out, and there it is. Without any hitches. I should open it in some other software to show you how much it lags, because this seems like it's it just simply works, but no, it's actually impressive how fast it is. And if I double click it and I go into the block editor, works like a charm, right? And I can go in here and I can edit all of these lines. Well, okay, this one does not have that many control points, but red boy, there we go. This one, hey, that's a lot of control points, isn't it? And also you can see that it's kind of jagged. So this is where the regen comes in. So there are two ways of how you can regenerate the viewport. One way is by just doing this, I believe, or is it up and down? Yeah, it's up and down, right? And it's going to just simply, well, takes a while. It's a heavy file, but it's going to simply regenerate, right? Another way is just typing in regen and it's gonna work, right? This is fast. This is impressive. Just wanted to show it to you. If you have heavy files, the software will handle them. I'm happy about it. Okay, back to the video. So that took a while, but we do have ourselves a cleaned up drawing with all of the bits and pieces, all of them stacked into the material sheets that I own, that I have, right? So here it's hatched, all of the lines are separate. I have created text for every single landscape piece. Some pieces I managed to cram into one sheet. These are all 2.4 millimeter thickness pieces, and all of these are 1 millimeter thickness with red lines being hashed. And engraved, sorry, I'm tired. If we disable the sheet and the engrave preview, this is only the cut lines. Let's go for engrave. I can hide the cut. This is all just the engrave lines, right? So basically that's that. One last thing, I promise is the last thing. If I zoom in to the text, right? The text should be exploded. The reason for us exploding the text is because in doing so, we get rid of the hatch, the solid hatch that is inside of the text. That is quite an important thing to do, because if you keep the hatch, the laser cutter will go for rasterized engraving, which is much slower, right? So you want it to be your text to be lines rather than hatch. That's about it. Okay, let's move on to actually showing you how you export it for laser cutting, right? So you have your sheets, everything's ready to go. What you do is you select all of the sheets that belong to a separate material, let's say 1 millimeter balsa wood, and just export them separately as a DXF. Or it can be DWG as well. That's fine too. And you export it. You can also just simply save as. And here you can just choose to save it as a DXF file. That works too. Okay, and basically you will have the 3 files. Now we have a little bit of a problem, and the problem is called the laser cutter is in another country, in Lithuania, in my office in Lithuania. Very good architecture company, by the way. Check out the link in the video description for the office webpage. Check it out. Check it out. Anyway, so I need to go there, and that's actually what we're gonna be doing. Let's go. So this is where it gets tricky, because the laser that I'm using is called D1, Xtool D1, and it's actually this one right here. It uses its proprietary software, meaning that at this point the tutorial becomes a little bit split. Depending on what kind of software you use, you would export or your drawings into different types of programs, right? So the principles are still quite the same, right? We have our line work and we will be importing it into some sort of a plotter. Think of it as a 2D printer, right? Printing in 2D, except that instead of ink, you're using a laser line, right? So I'm going to show you this on the software that is used for Xtool D1, but for you it might be some sort of other software, again, depending on the laser cutter that you're using. The software that I use for preparing the lines to be laser cut for the D1 is pretty simple to use. It's called Xtool Creative Space, and basically it's a proprietary software for that particular laser cutter. Anyway, so what I've done is I've created a separate file for each different sheet, right? Each different sheet of the line work that we have prepared, and also I have separated them out into 1mm thickness material, 2.4mm thickness, and 2mm thickness material types, right? So we have, that's the landscape, right? So all of these are, each of these are one landscape slice. Okay, so if we go for 1mm and 01DXF, if I just grab that one and drag it in, you can see that it starts migrating. It says design elements are being loaded in. And if we wait a little bit, there we go, it just simply imports. And now this is where I can start explaining why do we use that green layer that we called sheets. That is for the positioning. We want our elements to not be positioned abruptly, like randomly, but rather we want them to be placed exactly according to the material size. Wait, let me, 1 second. Come on. To the material size that we have, right? And in this case, this is going to be 10 centimeters in thickness, and I'm using 50 centimeters in length, or was it 40 centimeters? I don't remember, right? So the positioning is important. That's why we preemptively draw the sheets. Once the sheets are placed in your cutting software, then what you need to do is just delete that layer, right? We don't need it anymore. Are you sure you want to delete the layer? Yes, I am. And now we're left with layer 1 and layer 2. In terms of these separate layers, we will have one of them set to be cut. So layer 1, the black one, is going to be the one that's being cut. And here for the settings, we can either, in this case, I can either choose a material that I already have kind of saved into the system, or I can choose the power and the speed by myself. So I always use 100% power for cutting. And then I adjust the speed according if it's too slow, too fast, and so on, right? So these two knobs, so to say, are available for any laser cutter, and they're the most important thing. How strong do you want it to be, and how fast do you want it to cut? Each laser is different. Each laser comes with a separate sheet of materials that have power and speed listed on them. I will not be giving you guidelines because that would be a very bad idea if you're using a different kind of laser, right? But the general idea is that you have your power, you have your speed, and you adjust them according to the material. Then for layer 2, which is our red lines right here, we will have scoring set rather than cutting, or you can, honestly, you can use cut and just reduce the power. That's literally the same thing, but I will try out score like that. I will, for the power, I usually go for around 50-30% of whatever power was used for cutting beforehand, right? So if something cuts at 100% power, then I will use 30, maybe 40% of that power to score the material. And then for speed, I will also use probably double or even triple the speed, right? With all of this done, we can now actually start setting it all up and start cutting, because it's all Wi-Fi based. So let's go for the laser cutter.